Hey everyone, welcome to the Texas Data Tribe. In this video, we're going to review the foundations of SQL through a hands-on SQL bootcamp that I've designed to help build real-world data skills. This series will use Snowflake, but all the concepts that we're going to learn in this video and in other videos can be used with the various other databases that you may come in contact with, such as MySQL, Postgres, or SQL Server. There are quite a few different variants of databases out there. We won't get into all of those in this series, but we will mention a few of them. The video will stay focused primarily on Snowflake, but you will hear me sometimes mention some of the other variants that I just mentioned before. Maybe we might throw in some references to Oracle, things like that. This video is going to begin by teaching you the basics, such as what is SQL, how is data structured, and briefly review how to navigate through the Snowflake interface, since that's what we're going to be doing, pretty much through this entire series, is using Snowflake to go through all of these concepts. At the end of this video, we're also going to dive into what does a query look like for SQL, writing your first query, and I'm even going to show you how that works inside of Snowflake and execute it. If you don't have Snowflake, feel free to follow along in any database that you might have access to that has some sample data in it. Just understand that your database names, your schema names, your table names, all these things we're going to learn about in this video, those are going to be different based on your unique environment. If you are using Snowflake, or if you would like to, you can go sign up to Snowflake and get one of their 30-day free trials. This is a great way to take this course. If you want to switch over to a paid version, it's a pay-as-you-go type model. We're not going to really be uploading our own data into Snowflake at any time in the near future. So you won't really be paying for any data storage, since Snowflake does include demo data within their environment that you're not charged for. So during the course of these videos, this one and every other video in this series, if you want to follow along in Snowflake and you don't have a Snowflake instance today, you can sign up for a trial, as many trials as you would like to sign up for, or you can sign up for a trial that you switch to paid version and you can pay as you go. The great thing about Snowflake, since it is pay as you go, is it is relatively cheap as long as you remember a few key concepts about warehouses, which we will also discuss in this video today. By the end of this video, writing your first SQL query is going to be the main goal. There are, like I said, many other concepts, mainly to do with Snowflake and Snowflake warehouses. I would recommend kind of reviewing the chapters down in the description below, clicking through to the chapters that are most important to you, and to the chapter at the very end where we start reviewing what a query is, if you are not using Snowflake. But if you are using Snowflake, stick with us to the whole video because there's a lot of good content coming your way. So what is SQL? Well, at the end of the day, SQL stands for Structured Query Language, and it's the standard language used to work with structured data. This is going to be things that are stored in rows and columns, so think like spreadsheets or databases if you have some exposure to what a database is. Now, some people pronounce it SQL, as I'm doing in this video, and others choose to say SQL as an acronym. Both are totally fine, and you're going to hear both throughout the industry. I will use both versions interchangeably to get you familiar with both usages, but do feel free to adopt whichever version is more comfortable for you. So SQL is a database manipulation language, and both the American National Standards Institute and the International Standards Organization, wow, that's a mouthful, right? Accepted SQL as the standard for relational databases. SQL powers many data jobs by letting you easily access, analyze, and manage your data, from BI dashboards to AI, even machine learning. It's really an essential tool to unlocking insights and making smarter decisions about the data that you're working with. As a language, SQL was created by IBM in the 1970s, and it's grown tremendously since then, including database-specific variants. You might find when working with Snowflake, SQL Server, or even Oracle, that there are some SQL functions that work in one database but not the others. Each organization has really tried to add to SQL's capabilities to make it more user-friendly, but in this series we're going to focus almost exclusively on those capabilities that are standard across all platforms. In the SQL world, we call those either ANSI standards or ISO standards, again referencing back to those two organizations that have tried to set a standard language for relational databases. When people talk about writing SQL, they usually mean writing queries that ask questions of the data, like show me all customers from Texas, or what were our sales last month. SQL is used by analysts, engineers, developers, and data scientists. It's going to power your dashboards, drive your automations, and support business decisions every single day. Before we start writing SQL, it helps to understand how databases are structured. The easiest way to explain this is by comparing it to Excel. Now, this is just my way of, kind of breaking it down, helping people that may not know what a database is, but wants to break into this field, really understand it in, a conceptual way that they might have come across before. And Excel is pretty standard across any job that might touch a computer these days. So the term database can be used to describe the program, like Excel is a program, Snowflake is a database program or platform, SQL Server is another platform. But then the word database can also be used, think of it as the folders on your computer where you store your Excel files, My Documents, or maybe you have various different folders that are named for projects or for departments. Inside of the database, you're going to have what's called a schema. And schema are like the individual Excel files, or as Excel calls them, workbooks that group all of your data together. So when you open up one of those folders on your computer, you're going to see a list of Excel files or Excel workbooks, and that's kind of how you can think about a schema. Table is where all of your data lives. So this is going to be when you open up an Excel spreadsheet, the rows, the columns, all the little tabs at the bottom. Think of each tab or sheet in a workbook as an individual table, and the data within that tab or that sheet is going to be the rows and columns of the table data. This hierarchy that we're kind of talking about, this database schema table hierarchy, it really helps keep things organized in a database world, and it is pretty consistent across many data platforms. Now, before we dive too deep into, kind of what we're going to be reviewing today, which is the anatomy of SQL queries and, what makes up a SQL query, and even writing our own very first SQL query, it's important to, understand Snowflake, because that's what we're going to be using throughout the entire series of this course. And Snowflake has, some very unique properties to it that makes it very powerful, makes it very easy to use, but you do need to have some of that foundational understanding. Snowflake has a web interface, which they call Snowsite, and it's where you manage your compute power, it's where you write your queries, it's where you can explore, upload your data, and it's all done from within your browser. So there's no downloading tools onto your computer and having to worry about, does the tool look the same on Mac versus Windows, and what happens if I'm watching this video as an example on a Windows but it was recorded on a Mac, or vice versa. Being within the browser makes it very flexible, or being cloud-based. Within Snowsite, there's a few main sections that we're going to come across. There's so many to think about and to look at, and we'll pull that up. But by and large, within Snowsite, you can administer your Snowflake instance, you can administer your warehouses, you can see cost optimization, you can explore your data, and you can even open up worksheets to write and run SQL queries. Navigating these areas efficiently will definitely speed up your workflow and help you manage your resources and data. So this really does make Snowflake a powerful and user-friendly platform for data professionals, both those that are seasoned and those that are just breaking into this space. So let's pop over and let's take a look at what Snowflake looks like. So I'm logged into my little demo account here, and so when you first land inside of Snowflake after logging in, you're going to be presented with the home screen. And then along the left-hand side here, you're going to find a series of navigation links that you can drill into to really work your way around the platform. Starting with admin as an example, the admin section gives us some information about cost management, warehouses, compute pools, so on and so forth. The list goes on. From this section, we're mainly going to be focused on warehouses. And we won't really break out of this too much since this is more focused on learning SQL and less focused on becoming a Snowflake expert. But just to kind of dive through the rest of these, Snowflake does have some built-in monitoring, so you can see your query history and query runtime. We will use this a little bit in some later episodes because we will start talking about, now that you've got more advanced queries, how do you optimize those queries so that way they can run faster? And looking at your query history is going to be very critical in helping to understand, what query ran, who ran it, how long did it run. You can see over here there's a duration column. Understanding all of this information. And all of this plays back into two things. One, how quickly are we returning data, because the longer that someone has to wait for data, whether it's a web page or report or a view or what have you, the less the user experience is, going to be that great. The other reason why is if you're using something like Snowflake, you do pay for your warehouses, and we'll get into those a little bit later in this video. And so keeping that query execution duration as short as possible is going to really save you money in the long run. And we'll talk about some of the ways, very high level, about how we can pull that duration down. And in later videos, we'll dive a little bit more into it when we start talking about optimizing SQL queries. Again, just kind of coming back over here to the left, we won't really dive too far into AI and machine learning, but it is important if you are going to be using Snowflake and you want to take your journey beyond just the basics of SQL and what this boot camp is going to cover, that there is an entire Snowflake AI and ML studio. And a lot of what they have, they've labeled Cortex, and so that's kind of their branding for large language models and things like that. Within the studio, there's a lot of out-of-the-box structured data for machine learning, LLMs that you can use. You can help fine-tune them, you can try them out. They've got some analysis, some Cortex searching, document AI. So if you have a lot of unstructured data, so think PDF documents, invoices, receipts, emails, things like that, you can bring those into Snowflake, and Snowflake's Cortex program will kick in and help bring that data into a usable data format that you can then use in your SQL queries that can be then pushed downstream to BI dashboards, other AI and machine learning models, or whatever the case may be. Data products, this just talks about the data software, if you will, that has been developed for Snowflake. So they have this cool little thing called the marketplace. And so you can go in here and you can find tons of really cool tools that you can install within your Snowflake environment that just kind of makes your life easier, or maybe provide some out-of-the-box integrations that might prevent you from having to reinvent the wheel. And the other thing that's in here is this concept of data sharing. And so what this means is that companies or organizations can format data into tables, and they can share those tables out to other companies, and they can share that data out for free. So on my screen here, you can see that WeatherSource has weather data that they've put into a data share, and it's free for you to pull down into your Snowflake instance. So if you're dealing with something like solar or travel industry or things like that, and you want to see how weather is impacting your cells or your installations, you can pull that weather data in and you can tie it up to all of your other data, and you can see a very holistic view of how your cells do on sunny days versus rainy days. The other thing that you can do is, if you have data that you feel would be useful to other companies or the world as a whole, you can package all that data up and you can share that data for a fee, and you can charge people to access that data. And we've seen some of this in healthcare industry. Right here we've got different things like the CRM platform data for HubSpot. So you could look at sales, service, marketing, and website data. So there are a number of different marketplace apps and shared data that you would have access to. And again, we're kind of just spending a little bit more time on this because as we start diving deeper into later series, you might want to start leveraging something like dbt for data transformations. And it's important to note that there are some great tools within the marketplace that brings dbt functionality natively into Snowflake. Or perhaps you want to start playing with some other data other than what's in the Snowflake sample data. So pulling in perhaps this weather source data source would be a great way for you to have some other data that you can play with and manipulate. Now, the next two tabs here on the left, data and projects. So this is where we're going to spend a lot of our time. And we will dive into data first. And so within data is really where we're going to see a lot of features that Snowflake has added just within the past few months. But the one we're going to focus on specifically is this database section. And so you can see here it's opened up quite a few things on the right hand side. We see a number of databases, and the great thing about Snowflake is that everything is role-based security, and it can be very granular as you want it to be. You can see down in the left-hand side, we've got my name, and we can see this account admin, which is the role that I have. And so if we were to go to role, and we were to change my role over to the Texas Data Tribe, everything refreshes, and you can see that now the screen looks a lot more clear. So again, this is another great tool to use if security is important to you. Segregating data out by teams or by users is important to you. And for the duration of this entire series, we're going to stay in this Texas Data Tribe role. That's going to kind of help pull back some of the kind of screen noise that you're going to see as we're walking through Snowflake. The one exception is we will switch back over to the account admin role when we dive into warehouses a little bit later in this video. Now within the database data concept, I call this Data Explorer, and I didn't want to jump straight into that term because you can't actually find the word Data Explorer in the navigation menu. You can go through and you can explore individual databases. So here we're going to use the Snowflake sample data database, and it's denoted by this little database icon. And it's also really cool to note that there's this little bitty overlaid icon that says that this is a shared data source, meaning I don't own this data. It's all maintained, updated, deleted, refreshed by Snowflake or by whoever owns the share. And then within that, you've got some different schemas. So, I kind of talked about databases. It's kind of like a folder. And then within the folder, you've got different files or schemas. And then within different schemas, you have different tables. And if we click on one of these tables, we'll click on the customer table as an example. You can see over here that there's various columns, what kind of columns they are. They number, variable character, meaning that it could be numbers, letters, symbols. Finally, what we're going to look at is we'll briefly look at worksheets. And so worksheets is where we're going to write all of our SQL queries. You've got worksheets, notebooks, Streamlit, dashboards, all these things. We might dive into them in some later episodes. Your feedback is important, so drop a comment down below if you feel like you'd like me to explore these more. But worksheets is going to be primarily where we are working from. I do think it is pretty cool that there's this new workspaces. It's in preview, so based on where you installed your Snowflake instance, and for anyone that has signed up for the free trial, you're going to be able to pick if you want it on Google Cloud or GCP, on AWS, Amazon, or on Microsoft Azure. But just know that every one of those, when it comes to early access and preview functionality like workspaces being in preview, may or may not always get everything at the same time. For me personally, I choose to always set up my Snowflake instances in AWS because it does seem that AWS tends to get things first more often and earlier. So that's just a personal preference for me. And definitely don't take that personal preference to heart because there are other factors that you might want to consider when you are picking your region or when you are picking the platform, the cloud platform provider that you want to use. These could be if you are a GCP shop and you have a lot of data inside of GCP, you probably want your Snowflake instance also on GCP because there are a lot of network policies and things like that I don't even pretend to know everything about that you can take advantage of that makes moving data between the two systems faster and cheaper and easier and more out of the box point and click type stuff. But again, I tend to lean more towards having it on AWS just so I can have more early access to preview features. So jumping into worksheets, we'll dive into kind of what this is. So you've got your recent tab here, which goes through what you've opened recently. You can share your worksheets out to other users within your Snowflake environment. So I can view files that are shared with me. We won't click into this. I don't really have anything shared with me, so nothing really here. My worksheets are going to be the things that I own based on just a list of worksheets, and the folders get mixed in. Or if you just want to view just straight up folders, you can go directly there. At this point in time, Snowflake doesn't allow you to really set what you land on when you come to the worksheet section as a whole. For me, I would like to land on the folders tab. whenever I come into here, because I do try to organize things by folders. It's just not an option today, but I try to keep it as clean as possible. And then within a folder, again, you've got your worksheets that we can work in. And we'll open this a little bit later in this video when we start writing our first SQL query. The only other thing that I will denote here is that there's this type column called SQL, and that is because when it comes to worksheets, Snowflake does support other programming languages besides SQL. So if you are doing advanced data cleansing, data wrangling, AI, and machine learning, maybe you're using something like Python in addition to your SQL or your SQL, and you want to be able to have your worksheets all live in one place. So that is something that you can do all within Snowflake. And another reason I kind of lean towards Snowflake a little bit. Now, flipping back over to our slide, let's talk a little bit about a Snowflake compute warehouse. So a compute warehouse, it powers and runs your queries and workloads. You have the ability to start, stop, and resize your warehouses at any time, which will save you on cost and can increase your performance as well. And the costs are based on warehouse runtime. So if you have more efficient queries, meaning that they run faster, this is going to translate into lower cost. So when we're thinking about a Snowflake compute warehouse, or as Snowflake calls them, just a warehouse, think of it as what actually does the work. It provides the compute power that you need to, again, process your queries. And I call them compute warehouses because the term warehouse and the whole sphere of the data world actually has multiple connotations. So we have a data warehouse, which refers to where data is stored, and a set of standard models that you might lay out your tables and your schemas in within that data warehouse to make it better organized, have better relationships between your data. But then if we're looking at Snowflake, obviously they call a warehouse that individual thing that you turn on and off when you are running or not running queries. So again, we can think of a warehouse in Snowflake terms as the engine that runs your SQL. And when it is running, it consumes resources so that it can process those queries, and you are being charged for that runtime. But then when you pause it or turn it off, you are not being charged any longer. And again, it's why I say that if you have the free trial and you can't complete the series of videos within the free trial, it doesn't hurt to throw a credit card down and go ahead and sign up for the full version of Snowflake. Keep your warehouses turned off, and you will only be charged for what you use. I think the price per credit is somewhere around $2 a credit these days. So not very expensive when you're just turning them on and off very quickly. Now, it is important to note that Snowflake stores data separately and charges you separately than your compute warehouse. So when you turn a compute warehouse on, it will cache data as you're running queries, and it will cache your queries. But when you turn that warehouse off, or it suspends, all that cache goes away. So you're not actually charged for that. Your data is charged at the storage layer, and it keeps those two things separate. And so again, that's why I say if you're following along to this video, we're going to try to stay within the Snowflake sample data database. And that will mean that you shouldn't have any storage charges at all unless you choose to upload files or data directly to your Snowflake instance. And all of your data, again, lives in tables and accessed by warehouses. So when you turn a warehouse on, it can go out and it can grab data from those tables and bring it back to you to display. So at this point, we're going to actually dive in and we're going to create a data warehouse in Snowflake to process all of our SQL queries. So I am going to switch back over to the account admin role because this is an admin functionality. And then I'm going to go over to the admin section on the left-hand side, and I'm going to click into warehouses. You can see I have a few different warehouses here. But we'll go ahead and we'll create a new warehouse just for the sake of this demo. We're going to call it Demo Warehouse 1. And it would help if I could type today. And then there are a few different things that you can do. You can add a comment. So this is great if you need to denote like in a data catalog or just in data documentation, what a warehouse is used for. You can also select a type and you can select a size. Now, kind of backing up through all of this, taking it from the top, you can have as many or as few warehouses as you want. And there is definitely the concept of warehouse sprawl. And you really have to learn when is the appropriate time to have one warehouse versus having many warehouses and where that dividing line is, because there is a diminishing point of return. If you have too many warehouses, you may end up paying a lot, because when a warehouse comes online for the first time, you are automatically charged for 1 credit. And you can see down here in the left-hand corner, it's 1 credit for every hour that this warehouse runs. And you turn it on for the first time, you are deemed for a credit, but then you want to get it turned back off before that hour is up. The other thing is that adding comments can also kind of help delineate that. Maybe the warehouse names aren't that informative, aren't that descriptive, so you put in a few comments. I have definitely seen environments where they have a warehouse for performing data functions with a developer. They have a warehouse that is used by automated tools for bringing data in and cleaning data up. They have a warehouse for their analytics, and they have a warehouse dedicated to their AI and machine learning. And again, it just depends on a few different factors, how you want to divide it up by teams, also the sizes and the types of the warehouse. Some types and some sizes are better for some jobs than others. And then, of course, diving into your advanced settings. And so through here, we've got 2 settings that I always kind of recommend staying on is auto resume and auto suspend. So auto resume is a way of activating a warehouse the moment that a query is requested to be ran. And so if I go into a worksheet and I run a query using this demo warehouse and I don't have auto resume on, the query is not going to run. I would have to actually go back out, go to the admin section, and turn this warehouse on manually, and then go back and try to re-execute my query. So just easier to have auto resume on, though I will say in some business instances, there are use cases where you would not want this functionality to be available. The other, and I can very rarely think of a time because you have control over the minutes of inactivity here, is auto suspend. And this is what keeps you from getting thousands of dollars in bills at the end of the month because you got distracted, or your power went out, or you lost internet access and you couldn't turn off that warehouse after using it. And so you can go down here and you can set the auto suspend time, where if that warehouse has not run a query for so many minutes, it will go ahead and turn it off for you and start saving you money. The last couple of things down here are multi-cluster warehousing and query acceleration. So query acceleration, we'll start there first. Exactly as it says, it's flexible compute resources to make queries run a little bit faster. And then there's multi-clustering warehouse. So we're going to check that on, and that brings us back to your warehouse types. Again, for this, we're going to stick with their Gen 1 warehouses, but it is important to know that new warehouses have come out in Gen 2 because of improvements in hardware, improvements in software. So performance is better. They are a little bit more costly. And then there's the Snowflake optimized warehouses. And these have larger memory and cache. And so these are good for very intensive data analysis type things. So think about projects where you're mixing SQL and Python together. You might want a Snowpark optimized. But we're going to stay with Gen 2, and that brings us over to size, which also plays into multi-cluster. And so again, we'll be very, kind of high level here. The size of a warehouse determines how much data that warehouse can process at one time. So if you're returning, 50, 100, 200, 500, 1,000 records of data per query, an extra small would probably be pretty good for you. And as you go up, it does get more expensive per credit hour, and you can go up fairly large as 6XL. And this is for the amount of data you're working with. So the larger the data in your table, the larger you're going to want your warehouse to be. Now, multi-clustering is essentially cloning a warehouse and making a duplicate of it. So minimum is 1. So when we turn it on, we're going to start out with 1 warehouse, but we want it to be able to go up to a maximum of 2 or to a maximum of 20 or whatever. And you can select your scaling policy. So minimize queuing versus economy to minimize impact on credits. And what multi-clustering does is if size scales up and down, multi-clustering scales in and out. And so think about a single warehouse that's being used by 5 people, and all 5 of those people kick off a query at one time. Well, in smaller warehouses with no clustering, some of those queries might go into a queue. They might run really fast, but if someone else has already taken up the server resources on the warehouse, it doesn't matter how fast that person's query is going to run, they still have to wait in line for the resources to become available to them. And so multi-cluster warehousing was Snowflake's solution to this problem. It allows it to automatically scale up the number of clusters or resources on a warehouse to cut down on the amount of time that a query spends in a queue waiting to run. Standard policy pretty much scales it immediately the moment something hits the queue. Whereas economy policy says, hey, something's in the queue, but let's wait a second before we automatically scale up and charge you for more. So a lot of flexibility and a lot of power here when creating your warehouses. Now, the next thing that we're going to jump into is we're going to jump into the anatomy of a SQL query. And to do this, we're going to talk about the structure of a basic SQL query and what makes it up and kind of review a few things. So in order to write your first query, it is really important that you understand the building blocks. And these building blocks that we go over today, they're going to be the bare bone basic building blocks, and we're going to add to these in later episodes. So, good slide to, screenshot out. I'm going to drop a copy of this slide deck down into the description below, so you can feel free to go down and download that, keep it for homework or later review. But these building blocks are going to be built upon as we continue this series, and they are very important to understand, and we'll get into why. So each SQL query begins with what we call a keyword. Some examples of these keywords, and there are many, would be select, insert, or update, and it tells the processor the type of operation that you want to perform. And they're also very, self-explanatory in a lot of cases. Select is exactly that. You're pulling data down. Insert is you're pushing data into the table, and update is you're changing some kind of data in that table. So again, whenever we start looking at these keywords, the others that we're going to look at that are pretty standard is the from keyword, and this specifies what table we want to use. So in addition to having select or insert or update or even the delete function, we also need to tell it what table to execute that against. And then the last one, which is optional, but I like to view it as a required keyword. And again, as you get into the business, you'll learn when it is and isn't necessary, is the limit keyword. And, think about a table that has 2 million records of data, and you say, give me data from that table, and you don't put a limit on it. Well, you're going to get 2 million records of data back. So limiting allows you to kind of dial that down to something that's a little bit more consumable, more bite-sized pieces that you can jump into and take a look at before you go into more advanced SQL querying. Now, even though we write queries in a specific order, so in this case, select, from, and limit, the database actually processes them in a different order. It actually starts by evaluating the from keyword first because it has to determine where to pull data from. Then we jump into the select keyword, which tells us what columns from the database we want to pull down and look at. And then finally, we use the limit keyword to help trim down the amount of data returned so that we as humans can have something that's a little bit more digestible to look at. As queries become more complex and we add more to this order of operations, you'll notice that the order that we write queries and the order in which they are processed will look dramatically different. And understanding the process order is just as important as understanding the order in which we write them. Whenever we're writing a query, if we don't have them written in the correct order, they're not going to run. But then likewise, when we're processing a query, especially a large query, it's really good to know the order of operations in which things process, because that can help us increase the performance of those queries, make them run faster. And we'll get more into that as we start moving into later videos and we start exploring other keywords that we can combine with this basic query that we'll be looking at today, and making your queries more powerful. All right, so we're going to come back into our Snowflake environment, and we are going to go to Worksheets, and I've just navigated to my little YouTube Bootcamp folder and our episode 1 file, and we're going to go ahead and pop that open. And so again, on the left hand side, you're going to see another nested menu, and this is going to show us, very similar to the Data Explorer we looked at earlier, another Data Explorer that we can kind of pin through here and look at. This is very helpful to have because sometimes you might forget the name of a schema, the name of a table, or maybe you want to click a table and you want to see what columns exist on that table down here. And you can also see how many rows of data that table contains. The other thing that you can do is, if you don't want to look at your databases, you can also look at your worksheets, and nice little hierarchical tree view over here that shows all of the worksheets that you have available. Kind of going back over, we're going to scrunch that down just a little bit, and we're going to go to the meat and potatoes of a worksheet. And so what we've done up here at the top is we've set up some of our demo environment type settings. Even though these are for the demo environment, I always recommend making liberal use of these types of usage functions, and we'll get more into those later as we talk about different worksheets that we're going to be developing in. But again, this is very Snowflake specific, and if you are not using Snowflake, you can completely ignore this piece, but this is our way of telling the worksheet that we want to make sure we're using the correct role, that we're making sure that we're using the correct database, and that we're making sure that we're using, most importantly, from a cost perspective, the correct warehouse. And then we get to the basic SQL query, and this is the select query. And so I'm going to go ahead and I'm going to run my demo environment and get that set up, and we'll bring it on down a little bit, make some room up here, and let's go over the anatomy of a select query. So select query can be written in one line. You can move it to multiple lines. There's no real rhyme or reason to how many lines you move it to, how you space it out, all that kind of stuff. But we've started here to show just a basic one-liner, and we'll break that out a little bit when we start adding some custom columns. And so the most important thing to look at is that I can break it down just like this, and it is the same exact query that I had before, and it makes it a little bit easier to read. And so we'll start with the from statement, which again is the first order of operations on the processor side. And this is telling us the table that we're pulling data from. Now, because I have told this worksheet that I want to use the Snowflake sample database and that I want to use the warehouse, I could leave, when I run it, I could leave that off because this warehouse and this role both have access to this database, and I've already said use this database. So I could leave this piece out, and then I could just have the schema or the customer. Likewise, I could do a very similar thing up here where I say use the schema, and I could leave all of this out and have just the table name defined. Now for me personally, I do like to include the table name and the schema name, because if I forget to set my environment, or if I'm in a different database and didn't realize it and I try to execute a query and perhaps it's a destructive query like deleting data, I want to make sure that the table that I intended to delete data from, that I intended to update data from, or the table I'm reporting on data from, it is the table that I truly intended. So this removes any ambiguity that the SQL engine might have about what specific customer table you are talking about. Moving up into the second order of operations here is the select query. And so what we've said here is select, which is pull data. And then we said star, and I put for this table down here at the bottom the different fields, and these are all the fields that live on that table. By saying select star, think of it as a wildcard. It's going to pull all of these fields or columns into my view down here at the bottom, and we'll see that here in a second, and I'll be able to see all of those columns. And then the last thing is I've limited it to 10 records of data just to make it a little bit more human consumable. So let's run our first query. And there we have it, folks. So the query is run. You can see over here on the left, it has returned 10 rows of data. And you can see scrolling left to right that all of those field names or column names that I've put here are represented here. And within each row and column cross-reference is a piece of data. And you can kind of see what that looks like. Now, Using the limit, as you can see, does make this very human consumable. As you continue to increase the number of rows, there's a lot more scrolling you have to do, and it's a lot harder to kind of catch things. But there may be use cases for pulling more data or removing that limit. The other thing is we're now going to change this query, and we're going to change it for two reasons. One is to show you that you don't have to use a wildcard in your select statement. You can actually define the individual column names that you want to pull in, which makes this even more easier to read. But then the other thing is, again, selecting from star, which is kind of what that is called in the SQL world. If you have a table that has 50, 80, 100 columns on it, and I have seen those tables, people, that's a lot of columns of data to pull. And remember, the more data you pull doesn't only make it harder for you to read, it also takes longer to pull that data. So when we're thinking about optimizing our queries, before we jump into getting too technical with query optimization, the first thing that we can do is we can look at the number of columns we're pulling and get rid of any columns that aren't important for our report. So we'll go ahead and we'll take that star out, and I like to go down a line underneath and indent it over. It just makes things a little bit cleaner to read. Adopt whatever standards are comfortable with you, or if you're working for a company that has standards established, go ahead and adopt those. And we're going to pull in the first column of customer name. And so we put that in here, and then you put a comma. And I always put my commas in front like this, but I could also alternatively put the comma at the end. And again, this is a personal preference, but I put my commas here, and then I want to pull in the address. I want the customer's address, and we'll pull in C account val. And so we'll select that query again, and we are going to run that query. And now you can see that we have more human digestible data to look at, and we're looking at data that we really care about. So we're looking at their name, their address, and what is their account balance if we're thinking in terms of the banking industry as an example. So that is the basic anatomy of a select query, and we're going to take it just a couple steps further before we conclude this video, and that is to look at code comments and also column aliases. And so a code comment, just to start out, is something like this. So a single line comment always starts with a dash dash, and then you type out what you want your comment to be. And so if I highlight that and I click the run button, you can see it says empty SQL statement because it doesn't recognize this, it ignores it. And if I select the whole thing and run it yet again, I get my 10 rows back with my 3 columns selected, and it doesn't say anything about what my comment is. So use these very liberally in your code because it really does help you understand why you did something. I have 100% gone back to code that I wrote 3 months ago and wondered why I did something the way that I did it. And I'm sure that there was a reason, unless I was just sleep deprived people, but at the end of the day, I didn't comment that code, and so I had to sit there and try to remember, why did I write it this way? What was I solving for? What was the problem or the question that needed answered? The other thing you can do is you can also do code blocks. So where this is a single code line, begins with the dash dash, and all the other stuff is just stuff that I put to make it look pretty. It's not required. You can have a code block, so I don't have to go dash 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 all the way down. So you start this with a forward slash and an asterisk, and then you put everything you want in the code block, and then you do another asterisk and a forward slash. And so everything that's between those two symbol combinations is considered ignored in your worksheet. Now, looking back at both this single line code comment and this multi-line code comment or a comment block, this is pretty standard across all of your database platforms. So this isn't something that's very unique and special to Snowflake, and so that's why we're diving into it, is because you can use single line and code blocks in many other data platforms. In fact, in most common data platforms, with very few exceptions, will accept code comments and code lines in this format. And the last thing that we will do to kind of round off our select statement is making these look a little bit cleaner using aliases. So see name, see address, see account balance. Those aren't very informative. But I don't want to go change that table's column names, because changing that could have downstream impacts on integrations or other reports being run. But for my specific report, I want to make this a little bit more human friendly. So I can put an as at the end, and I can put exactly what I want this column name to be called. So let's call it customer name. And then as, and then I can say customer address. And then again, I can say as, and I can say customer account balance. And now when I run that query, you can see I get the same columns and the same rows of data, but now the column names are a little bit more human friendly, human readable. All right, so switching back over, that is a wrap for this introduction to SQL using the Snowflake Data Cloud platform. We've learned today how data is organized into databases, schemas, tables. We've learned what a Snowflake compute warehouse is and how to navigate the Snowflake interface. And we even jumped into writing our very first SQL query. In our next video, we're going to take that very first SQL query and we're going to go a little bit further with it. We're going to look at filtering data down using a where clause or the where keyword. So that way you can kind of trim data down by state or by date or by country, whatever demographic or filtering or slicing you want to apply. We can do that with a where clause. And then we're going to look at ordering and sorting data. So whenever you get data back on the screen, maybe you want to see the most recent sales transactions first by the created date, and the oldest ones last. So we will look at sorting our data. As always, don't forget to like, subscribe, and follow for more from the Texas Data Tribe, and we look forward to seeing you in episode 2. Thank you and have a great day.